Hello and welcome back to Garry's Garage, and this episode we're going to try to do some science on the charge cooling system. So last time out we managed to get the car onto the rolling road and got some good results on the tuning, certainly at the lower end where I drive it most of the time, and it highlighted that my charge cooling system is just not good enough in its current state to deal with the high power, high throttle, high RPM range. So what I'm going to try to do before just throwing money at it is I'm going to try to do some science and see whether I can figure out what aspect of the system is not right and go from there and see if we can science it up. So my plan of attack is that with the system as it is at the moment, I'm going to try to run the pump and the cooling fans at different speeds whilst putting a hot air gun through the core. I know that that is going to have much less flow and much less heat overall than the turbos both compressing that air up to well over a bar and forcing it through at very high speeds. But what I'm going to try to do is run the test for a prolonged period. That may or may not have a similar impact, but I'm hoping that I will at least see some trends. So I'll do that with it all starting from cold. What I'll then do is I'll go out for a nice drive, get the engine nice and warm and hot so there's lots and lots of heat under the bonnet, and then I will do exactly the same set of tests, but with the whole system starting from a much higher temperature. So that should then give me some information on whether it's man enough to actually take the heat out the system once it's got there and not just keep going up and up and up with temperatures. And from there, well, we'll then have to see what other options I can come up with to try to make the charge cooling system less bad than it currently is. So let's get straight into the science, and the first thing I need to do is figure out how I can get some air blowing through the charge cooler and measure everything that I want to. So I figured I'd keep it relatively simple. I've already got two temperature sensors in the inlet. I have one that is post-turbo and I have one that is post-charge cooler. So why not just use this bit of pipe? So I've hooked my heat gun up to it. That's sealed with a little piece of rubber hose, and I've blocked up this end here. So we shouldn't get any air coming out from there. So all the hot air should come through the charge cooler and then exhaust out there. So I can use the logging on the ECU to record the air temperatures before and after the charge cooler. And the only thing that I can't really easily monitor from the ECU is the coolant temperature, but I do have this little temperature probe which I'll leave stuck in there, and periodically I'll check that and record alongside the others the temperatures of those. So I think the best thing to do now is to set up for the first test, and that's going to be basically where it's sat at the moment. So that's the fans at about 40% and the pump at about 50%, and we'll see what we get from ambient. Starting water temperature 20.9 degrees. So let's start that, and very quickly plug that in first, would really help. Okay, so we've got starting water temperature of about 21 degrees, and let's see what we have. So start logging, get the timer ready, start that, run around here, and let's go. The water's up to 22 degrees. Okay, water temperature is now 24. Okay, the heat gun is now regulating itself. Pulsing between high and low speed. So yeah, it seems to be able to push out about 150 degrees. So water temperature now is up to 26. Obviously this is actually kind of really low flow. I mean, the flow of air that's coming through here is less than there would be at idle. So that is definitely warm there, and it's definitely colder on that side of the charge cooler than there. So yeah, it's definitely at this rate keeping the air cooler. So water is up to 29.5. So yeah, the water is definitely creeping up, so I think that the radiator is not doing a good enough job. So possibly we need better fans or more speed on the fan. Maybe we need more speed on the pump. So whilst I'm pushing lots of hot air through it, or whilst I'm pushing hot air through it, I'm not really pushing very much air. I don't think we're anywhere near the limit or capacity of the charge cooler for actually cooling the air at the moment. You know, that's a decent reduction. But even so, the coolant temp is creeping up. So yeah, I think the radiator definitely is not man enough. Okay, I think what I'm going to do is at 10-minute mark, I'm going to turn the heat gun off, and then we'll see over the next 10 minutes how quickly it cools it down, and whether it can cool it back down to ambient. Within the next 10 minutes. Right, so first test done, and what I did realise when I was just fiddling around now is that the charge cooler pump wasn't being speed controlled, so I think it was just running at full tilt. I obviously got my wiring diagram ever so slightly wrong, and I thought that it was on one output and it's actually on the one next to it. So I've now corrected that, and I can now properly control the speed of the pump from within the software, which is great. So what we're going to do now, because that was obviously run at pump full speed, I'm going to run in the same test with the fans at the same, but the pump at a slightly slower speed, and we shall see what effect that has, because maybe the fluid was moving around so quickly that it couldn't pick up the heat from the charge cooler. Maybe it was just moving the fluid around too quickly for it to be able to pick up the heat properly and then also dump it out. So we'll run this next test with the charge cooler pump running at a slightly lower speed, but everything else the same. And again, we'll run 10 minutes of heat and then 10 minutes of cooling, or no heat and just the pump and the fans, and we'll see what the results are. It has crept up about 3 or 4 degrees ambient temperature since I did the test earlier, but pretty much we should be able to get a rough kind of comparison, I hope. So from that first round of testing, I think the conclusion that I've come to is that initially the pump was running at full speed. I wasn't powering it via PWM, so it was just running full speed, not the adjustable speed that I thought it was. So I think that means that the water was just moving around the system too fast and it wasn't able to stay in the charge cooler or the radiator for long enough to actually transfer the heat. Once I slowed the pump down, that seemed to make it a little bit better. And then the next best thing was to add more fan speed to get the heat out of the water back to the air quicker. So yeah, I think the charge cooler itself is actually drawing the heat in to the water, but then I'm not getting it back out of the water again. So the next thing I'm going to try is to hook up an extra fan to the front of the charge cooler radiator and just run this at full whack, run the same test again and see if, with a little bit more airflow over it, because those 2 fans I've got there are behind the engine radiator and they're not necessarily going to be pulling right the way through the whole of the charge cooler radiator, probably trying to draw more air from around it rather than through it. So this should force some more air through it, and we'll see if that makes any difference. If it does, then possibly I can go out and give that a try, but I think that maybe my radiator isn't big enough at the moment, and that is where my biggest issue at the moment is. I'll leave these graphs and the table of results up on screen for a few seconds, so if you want to pause the video and have a closer look, feel free. There are a couple of gaps in the table as I neglected to write a couple of the values down, but it does give a good overall view of the trend. So whilst that's not probably the most accurate real-world test, it does at least show that even with this weedy little heat gun, making a change to the pump speed and also the amount of fans and fan speed does actually have an effect on how much heat is taken out of the air, dumped into the water and then subsequently back into the air. But what it really does also highlight as well is that what I've got here just is not big enough. This barrel charge cooler was always a compromise. It was always sort of the smallest I could fit into the space, and it is rated for 260 horsepower, and that's 260 horsepower engine. I've got substantially more than that, so that is also definitely too small. And the radiator at the front, which is from a Subaru, that again is relatively small. It's not getting particularly decent airflow through it where it is and the fans that I've got, so I think that could do with something bigger. So I've been doing some measuring and lots of searching around, and I think I've come up with a couple of solutions to those, or certainly something that will make it better, and the first of which has arrived, and that is this charge cooler. So yeah, that's quite a bit larger. It is 250mm by 220mm by 120mm, and the inlets and outlets are currently 3-inch, which is way bigger than what I've got, and these inlets and outlets are also all pointing in the wrong direction. So my plan is to slice some of this off and remake some of that, and I'm hoping that that will fit in around about there-ish. Well, yeah, somewhere about there, maybe, or somewhere around here-ish. Obviously I need to be able to plumb it up and also pipe it up to the post turbo and to the throttle body, but that unfortunately will be a job for next time, because I have also, as well as this has only just arrived in the post, I've also been spending some time trying to help a friend get his Legnum VR4 through its MOT, and that is the annual test that we have here in the UK to check for roadworthiness, and it needed a couple of minor things done to it, so I have been helping out with that, and that unfortunately has taken a bit of time as well as I said, waiting for parts to arrive and doing the research on trying to find what would fit. The radiator that I've ordered, that is going to be coming at some point. I also did another full alignment of the car after finding that I'd left a couple of the suspension bolts on the rear not done up very, very tight. They were certainly not going to fall out, but they were just a fraction looser than they needed to be, which meant that the joints were moving around just a little bit, and as I applied power to the car, it moved the wheel in and out a little bit, and that I think was what's causing the car to go slightly to the side as I applied power. So I put a bunch of water on the driver's seat to simulate my weight, and then went about the alignment and managed to get everything pretty good. So all of the values are looking really nice and even now. The only thing is a 3mm difference in the wheelbase from side to side, but at the moment I think I can live with that. So I hope you have enjoyed this episode with some science-ish and some testing, trying to figure out what is going on with the charge cooler system. But like I said, that is all I have time for, so have a great day everybody and see you next time. Bye!